All right, so today we're going to multiply and divide fractions. We can't just do regular stuff like you've done because we've done that since 7th grade. Okay, we've got to, I'm going to start with those because this is what you're used to. We're going to have some conversations about these. And then we're going to go to rational functions like we've been working on. Okay, so we're going to transfer the knowledge we have here to these problems over here. Simple, right? Yes. Okay, so look at the very first problem. Let me zoom in, not out, in. All right. 3/4 times 5/7. What action is it asking me to take? Multiplication, right? It's asking me to multiply. How do I multiply fractions? Yeah, that's exactly right. Straight across the numerator and straight across the denominator. Okay? What is 3 times 5? 15. What is 4 times 7? Perfect. 28. What steps did I just take? We multiply numerators and multiply denominators. Does that make sense? Does that seem pretty difficult? No? How is it any different, though, when we have a problem like this? Or maybe I should say, is it any different when we have a problem like this? No, absolutely not. Multiply your numerators. What is 2 times x? 2x. Now, what we decide to do here in the denominator, first of all, tell me what to do. We're multiplying, right? So we want to multiply this binomial and this binomial. But depending on what we're doing with it, depends on how we write our answer. That will depend on what we do to write our answer. Okay? If it says just multiply, which is all it says to do right here, it is perfectly fine to write this as my answer. Excuse me. Think about it in relation to what we did yesterday. Remember we were finding vertical asymptotes, points of discontinuity, horizontal asymptotes? Can I go ahead and write it like this? X squared minus 3x minus 4? Absolutely. But if I was trying to find asymptotes, which one do I need it? The first way or the second way? First way, exactly right, because I need to take these and say, is there any factors in the numerator? If so, that's the discontinuity. If not, these are the vertical asymptotes, right? That's just a reminder from yesterday. But if it says like multiply completely, or if there's an example that goes from here to here, you know you've got to go to here, okay? But if on a quiz or a test, I give you directions of multiply, and you write this answer here, this first answer, there will be no points taken off because that is correctly multiplied. Now, if I say multiply like completely and give you an example to say I want it all this way, you got to go all this way. Fair enough? I will make it clear, though, so you will know. Okay? What? Oh. X times x is x squared. X times 1 is 1x. Negative 4 times x is a negative 4x. So when I combine those two, it gives me the negative 3. And then the last term, negative 4 times 1 is a negative 4. Does that make sense? Good question. Okay? Next example. Just so we're clear, we are talking about multiplying and dividing, right? Because, I mean, that's what the title of the worksheet is. So what does this say? Thank you. This doesn't say 2x 4 over 9. It says 2 times 4 over 9. Fair enough? Okay. How do I do this one? Wait, so you want to change it? Oh, wait, so you're not really changing it. So you're rewriting it into a form that you can do something with, right? Now, this is not required. But for visual learners like me, and like some of you, when we say multiply numerators and denominators, now we have a numerator and a denominator, don't we? We can just multiply here in my numerators and multiply here in my denominators. What is 2 times 4? What is 1 times 9? Done. What kind of steps did I take there? Well, I didn't multiply first, though, did I? So what do we want to call that 2? How about for argument's sake today, we call it a whole number? Okay? 2 is a whole number. I'm not arguing about that. But when we get over here, that's a whole nother story, kind of-ish. Sort of. Okay? So we'll say put the whole number over 1. Okay, hey guys, look up here real fast. Sometimes people use that as a hashtag. Sometimes people use it as a sharp. And sometimes people use it to represent the word number. Today we're using it to represent the word number. Or a pound sign. I forgot about that one. Thank you. Yeah, it could be a pound sign. But today, again, we're using it to represent the word number. I know I'm being silly. It's okay. After we put the whole number over 1, then what did we do? Multiply numerators. And? Very good. Multiply numerators and denominators. So how is it any different if I have a problem like this? Okay, so I still say 3 over 1. I multiply 3 times 8 and get 24 is right. Okay. And then I multiply 1 and x plus 6 and get what? X plus 6? Good. Any questions? Okay. What about here? This is where people get messed up. Don't be people. I mean, I want you to be people, but not people that get messed up. Put what over 1? Not just the x and not just the 1? Oh, the whole, that's the whole numerator, that's the whole denominator, right? And then what do I have left to do? Multiply the numerators, multiply the denominators. What's x plus 1 times 8? Oh, okay, so you said 8 times x plus 1, and he said 8x plus 8. Which one's right? Both. They're both right. It's exactly. Okay? Remember, that's a whole conversation like we had up here at the top in that first example. It really depends on where we're going next to how we need our answer written. And since you don't know where we're going next, since I don't even know where we're going next, I mean, as far as this problem, I know where we're going next. Don't get me wrong. Okay? We can leave it like this, or you can write 8x plus 8. And the denominator I have x plus 6. Yep, that's all right. Any questions so far? You doing all right? Okay. Number 3. What do you think we should do? Multiply straight across and straight across? What would we get if we multiplied numerators and denominators? 4 over 36. And somewhere in the back of my math brain, a little alarm is going off. Because 4 and 36 are both divisible by 4. So here's the deal. I'm a mathematician. So are you. Don't argue with me. That means we're lazy. We want to do the most amount of math in the least amount of steps with the smallest numbers that we can, right? So what if I said to myself, what if we simplify first before we multiply? Like, what's 4 divided by 4? 1. Wait, are you sure? Are you sure it's not 0? You're pretty sure? Good, you're right. Okay. 4 divided by 5. But this one's in this fraction and this one's in this fraction. Can I do anything about that? Yeah, absolutely, right? I can simplify this 4 with this 4. What's left over when I simplify those 4s? What's left over when I say 4 divided by 4? What's left over when I say 4 divided by 4? 1, right? There's a 1 here and a 1 here. It's not just gone. It doesn't just disappear. It simplifies to 1. Now, after we simplify, what can we do? 1. Because 1 times 1 is 1. Pretty sure. And then 1 times 9 is 9. Now, I did the same amount of steps. You wanted to multiply and then simplify. I said, let's simplify then multiply. Same amount of steps, but your numbers were way bigger than mine. Not that 36 is really a big number, right? But if you'd rather work with 4 and 36 versus 1 and 9, I would choose 1 and 9. Wouldn't you? We're lazy. We want to do the fewest amount of steps. Excuse me. We want to do the most amount of math in the fewest amount of steps with the smallest numbers that we can. Okay? So tell me the steps that we did. Simplify. What did we simplify, though? You know what those are called? Can I tell you? Okay. They're called common. Any guesses? Common factors. Then what? After we simplified common factors, then what? Multiply. Do I need to keep writing multiply numerators and denominators? Or you think you got that? So can I just write multiply? Well, you write what you need to write then. Jerk. So what about this problem? I'm just really glad you said it that way. You said to reduce or simplify the x plus 3. Okay? Which means you want me to do this and this, right? All right, let me show you something kind of scary. I mean, it's not going to frighten you. Like, no one's going to jump out of a cake or anything. Because, first of all, if I had cake, I would eat it all. Okay? What was it? X plus 3 over x minus 1 times 2x times x plus 3, right? You said cross out this way. You know what other people have said? Well, cross out the x and cross out the x, cross out the 3 and cross out the 3. If you can do that, if that is allowed, if this is true, I can also simplify this fraction by crossing out the 1s and crossing out this part and getting my answer as this. And you're laughing because it's ridiculous, right? Everybody knows you can't do that. Except that's what you're trying to do here. You're trying to cross out parts of a number. Yeah, you can't do that. Okay? If you think you can do this, then you can also simplify like this. And we know this is not true, so guess what about this? Not true. Okay? So I'm very glad that you saw that it was the whole x plus 3, the whole factor x plus 3, and the whole factor x plus 3. What does it simplify to? When I divide x plus 3 divided by x plus 3, what does that simplify to? 1. What's left over? Like that? 2x over x minus 1? So now I can cancel out these x's. Right here, right? Why? Why not? Well, one's in the numerator and one's in the denominator. Isn't that all it takes? No. If you can cancel these out, then you can do this. And we just decided you can't do that, right? This x in the denominator is part of this factor. And we can't take part of the factor. You have to take the whole factor. Okay? It's being added or subtracted to another number. Only way it's a factor is if it's being multiplied. This 2 is a factor. That x is a factor. That's fine. But this thing is not, this whole thing is a factor. I can't just take part of it. Fair enough? What about number 4? We want to simplify the 5 over 15 for sure. Okay? I'm going to write it in a way you may not have seen it before, but it's one of those things where I know where we're going, so I know what I need you to be thinking when we get there. Fair enough? Okay? So let's do it like this. You want to simplify the 5 and the 15. True? So I think to myself, well, 5 is really 1 times 5, right? And 15 is really 5 times 3. So what am I actually simplifying here? The 5s. That's exactly right. It's the 5s that I'm really simplifying. This with that. They're factors, right? They're being multiplied. So I can simplify the 5s. Is there anything else I can simplify? The 4 and the 6. How do I want to think about simplifying the 4 and the 6? Perfect. The 6 is 2 times 3. The 4 is 2 times 2. So what am I simplifying? I'm simplifying a 2. And what does it simplify to again? What's 2 divided by 2? What's 5 divided by 5? Okay, so there's 1s left over in those places, right? That's a 1, that's a 1, that's a 1, that's a 1. Okay? Oh, there's 2 3s, so I can simplify these 3s as well. Well, why are you saying no to me? I'm the teacher. Because I'm wrong. That's exactly right. Okay? I am wrong. Why can I not simplify these 3s? They're both in the denominator. What has to be true in order for you to simplify something like that? 1 in the denominator, 1 in the denominator. Okay? 1 has to be in the numerator, 1 has to be in the denominator. You even messed me up now. Thanks a lot. That's okay. It's a weird word. So what's left in the numerator to multiply? 2 and 1. And really a 1 here and a 1 here, right? So what's 1 times 2 times 1 times 1? 2. What's left in the denominator? Basically 3 times 3, right? We've got the 1s. We know multiplying by 1s is just going to give me whatever it is. 9. So what were my steps here? What did I do first? Kind of. What did I do right before I simplified? Factor. Factor and then simplify common factors. And then multiply. My M's look weird. Sorry about that. It does say common. C-O-M-M-O-N. Sorry. Don't judge me. Rude. So how's it going to be different on this one? Remember what your answer is? It's not. Exactly right. It's not going to be different. It's just kind of different concepts, right? This are just numbers. These are rational functions. This is linear. This is quadratic. Stuff like that, right? So it's a rational function. So first I have to factor. Can I factor that? No. Can I factor that? Oh, I can? Okay. Man, I should have shown you a video to remind you how to factor. Oh my gosh, I did. Multiplies to be 20, adds to be 9. Perfect. 4 and 5. So x plus 4, x plus 5. Yes. Yes, I am. Very smart. Can I factor this numerator? No. Can I factor this denominator? You're right the first time. What can I do? This whole thing, the 2x minus 6, what can I do to it? Well, yes, I can factor it. How? They both have a 2. Each term has a 2 in common, right? So I factor out a 2. Excellent. What's left when I factor out a 2? X minus 3? Okay. So I factored this one, so I'm not using it anymore. And I factored this one, so I'm not using that part anymore. I don't want us to get distracted. Okay? So what do I do? I simplify now, right? I factored. Now I simplify. What do you mean to simplify? X minus 3 with x minus 3, and that leaves what? 1. Okay. Is that it?
X plus 5.
Okay. X plus 5 and x plus 5? What does that leave? 1 and 1. So, wait, do we still have a numerator and denominator here? Or since everything canceled out, it's just gone? Oh, I still have a 1. Okay. So, what is 1 times 1? Excellent. 1. Over what? What's left in the denominator? Well, I have an x plus 4, and I have a 2. Don't forget that part, okay? So I have a 2 times x plus 4. Questions? I could write 2x plus 8, absolutely. Okay? As long as it was 1 over 2x plus 8. Okay? Before we go on to 5 and 6, I need to show you another example. I want you to go down to the bottom of your paper. See how I'm at the bottom of my paper? There's some room down here. And I want us to write 3x squared y minus 4xy squared over x squared y. Whoa. The problem with this is that it doesn't look like a multiplication problem. What do you think about that? Yeah, it's not, is it? It's not a multiplication problem. It's just a fraction, and what do you think they want us to do with it? Simplify it. How would we go about simplifying this fraction? So if you want to do it wrong, you'll cross these out right off the bat, right? I know they're exactly the same. So if you want to do it wrong, go ahead and cross those out. Because exactly, the 3 is attached to this, I just can't go in there, right? This term is being is subtracting this term, this minus this, and that means that's a whole factor. I can't just take parts of it out. So what do I have to do to the numerator? Is there anything common in both of the terms? Both terms have an x, and both terms have a y. What would happen if I divide xy out of this term? What am I left with? I'm very glad you said that. Someone who was not quite thinking earlier, not trying to say anything bad about them, but they said what was left was 3 squared. They just weren't thinking, right? They figured it out eventually, okay? What's left from this term if I factor out an x and a y? 4y, right? I took out an x and I took out one of the y's. Is there anything I can factor here, or is that already as low as it can go? It's as low as it can go, okay? So I have x squared y. Now, are there any factors I can simplify? What? I can do the y's now because it's a factor. It's this being multiplied by that. So that's one of the factors. That's one of the factors. Is that it? Is that all I can simplify? Yeah. Think about it. This is really x times x, right? So can I simplify one of the x's? Can I simplify these x's? Because the 3 is attached. And it's minus 4y. It's not, that's the whole thing is a factor. So what's my answer then? 3x minus 4y over x. Done. There's at least one homework problem like this tonight that you have to get done that I'm afraid you would mess up on and just go zhunk zhunk. So I wanted to show you an example. Okay? All right, so let's go back and look at 5 and 6. All right? Wait a second. How are 5 and 6 different? Ooh, they're dividing. You knew we had to get there eventually, though, right? Since the worksheet's called multiplying and dividing. I mean, it could be, this is a division problem right here, isn't it? 2 divided by 9, 2/9. Yeah. But we're actually doing dividing now, okay? So, you all either have your calculators or your phones on your desks in front of you, right? Wait, everybody has their calculator? Nice job. I want you to put this in your calculator. Don't press any buttons until I tell you to. Especially don't hit enter or return until I tell you to, please. Okay? I want you to enter this problem. 8 divided by 1/2. Don't hit enter yet. 8 divided by 1/2. Before you hit enter, I want you to say out loud what you think the answer is going to be. 4, 4, 4, 6, 4. Hit enter. 16. 8 divided by 1/2 is 16. I don't know. My guess is she didn't put 1/2 in parentheses. Or she didn't make it a fraction. Yeah.
Mine looks just like that.
Well, but see, this is 8 divided by 1 divided by 2. 8 divided by 1 is 8 divided by 2 is 4. If I want 8 divided by... Or you could just put 0.5, that's fine. Like 1/2. Like that. See where the darker division line is right here? It's right there. See, this is the darker division, the longer division line right there. Okay? So if we're saying 8 divided by 1/2, we're saying how many halves live in 8? How many halves live in 8? 16, right? How do we normally get from 8 to 16? We multiply by 2. That's exactly right. So are 2 and 1/2 related somehow? How? How are they related? How are 2 and 1/2 related? So you guys are saying flip them. Is there like maybe possibly a better math word for that? Reciprocal. So if I said 2 over 1, the reciprocal would be 1 over 2, right? So how are we going to attack this problem? We're not going to divide by a fraction. What are we going to do? We're going to flip what? Which one? There's 2. Okay, we don't just pick our favorite one. No, we don't do that. I'm saying 2/3 divided by 1/8. It's now going to become 2/3 times what? 8. Well, you can say 8 over 1. Probably don't say 8/1. But that was a good try. That was a good try. Okay? And then guess what? What do we do now? All of our regular multiplication rules that we've been talking about right up here. What do we get? Multiply straight across? 16 over 3. Exactly. So what steps did we take? We multiply by the reciprocal. Okay? Multiply by the reciprocal. I'm going to finish this video so you can go watch it when you're tonight if you need it. You have 10 homework problems. Go ahead and get those done. Okay? So when doing this problem right here, I'm going to rewrite this as 2 times x plus 2 because I'm factoring this as I go. I don't want to have to do a whole nother step later. Over x plus 3 times, remember this becomes a multiplication problem, and we're going to take the reciprocal of this fraction, x minus 2 over 5. Tell them to wait. Tell them to wait. Now, I look to see is there any common factors in this new multiplication problem. There are not, so I'm going to just multiply straight across. I get 2 times x plus 2 times x minus 2 all over 5 times x plus 3. Don't get carried away and recognize that there's a bunch of 2's here and think I got to be able to cancel out some of the 2's because this 2 is part of this factor and this 2 is part of this factor. I can't get in there anyways. I could simplify this 2 if there was something in the denominator that was divisible by 2. Okay? Last problem, same as before. Dividing by a fraction is the same as multiplying by its reciprocal. So I have 3 over 2 times 8 over 1. This time, however, we can simplify before we go. We can say this is a 1 and this is a 4. Then we multiply straight across. We get 12 over 1 or just 12. We multiplied by the reciprocal. Same kind of deal here. We have 4 over x plus 3. We're going to multiply by the reciprocal of this. So we're going to go ahead and write our first term. Multiply by, and before, or as I'm flipping this over, I'm also going to do the step of factoring at the same time, so I don't have to have a whole nother step for that. So what two numbers multiply to be 3 and add to be 4? Remember, we can do that because the leading coefficient is 1. X plus 1, x plus 3, all divided by x minus 7. And again, in this case, there is a factor I can simplify here and here. Now, don't try to cross out these x's because that can't happen. Okay, like we talked about before, that cannot happen. So we end up with 4 times x plus 1 over x minus 7. Okay, have a great day.